third session is open. I call Mr. Altman, Mr. Brown, and Mr. Hamidi, Dr. Hamidi. Welcome. Oh. Okay, honorable assistants. It's a great honor to chair this session where water meets energy. Indeed, the theme of today focuses on integrating water desalination in H2 economy. In this context, extreme events linked to the effects of climate change are becoming recurrent and increasingly violent on a global scale. Drought, flood, heat waves, etc. With this induced effect of climate change, the use of non-conventional resources, including water desalination, is an issue to fill the deficit and secure the water supply for different needs: drinking water, agricultural and industrial needs. On a global scale, the capacity of desalination plants will double by 2030, driven mainly by the countries of the Middle East and around the Mediterranean basin, but not only. Morocco, with its coastal potential on the two Atlantic and Mediterranean coasts, and which suffers structural drought cycles, has a proactive strategy oriented toward the intensification of building desalination units in the whole territory, resulting in a tripling of its current desalination capacity by 2030, which will supply the drinking water, irrigation, and industry sectors. To make this desalination resource, which is an energy-intensive industry, even more sustainable, the future desalination program will be developed using renewable energies, of which Morocco is capitalizing on its high potential. Also, the country has a proven experience in the development of desalination projects at different project sizes, which can be adapted to needs on a case-by-case basis and according to the different institutional modes of project management. Water desalination is de facto a main input in the green hydrogen ecosystem and can be incremented in an agile way in its value chain. The high technologies of desalination plants make for sure a positive social and environmental impacts. Like said this morning by the president of Cluster Green H2, Morocco is undertaking deep transformation in all its economic sectors and social behaviors to embark in the sustainable development revolution that will conciliate economic growth, equitable share of wealth, environment preservation, and climate change mitigation, under the high guidance of His Majesty King Mohammed VI, and H2 industry is a pillar among them. Be confident, especially in Morocco, that security of water will not be affected by H2 industry. On the contrary, it will be mastered by adding other desalination units shared between H2 and other water needs. Now, what about water requirements for hydrogen? So here are some figures. It takes about 10 kilograms of water to make 1 kilogram of hydrogen. Desalination represents less than 1% of the cost of hydrogen production. Desalination plants can be oversized to supply both hydrogen production and drinking water needs. And the last one, but not the least, hydrogen is more opportune to make in coastal areas to decrease logistic costs where seawater is available. Now, I let us the floor to other speakers to highlight different aspects of the Nexus hydrogen desalination. And I call Mr. Altman, who is an executive vice president from Innovation and New Technologies at Aqua Power. And I have one special question for him. Mr. Altman, what are the technical and economic barriers and opportunities for scaling up water desalination for hydrogen production, such as availability, and the cost of renewable energies and desalination technologies? Mr. Thank you.
Hello. Yeah. Thank you for having me here today in this extraordinary event. Thank you for introduction and the question. So when we talk about desalination, obviously the H2 from the hydrogen comes from the H2O, and so it's a critical input. Even from the CapEx perspective, as mentioned before, it's a small unit. It's still critical for the continuous production. So we need to look at all the aspects, how to make these small contributing units reliable. First of all, desalination plants exist for a long time, since more than 50 years, and especially in the Middle East, is the majority of the desalination plants, and now they have reached the size of almost 1 million cubic meters per day, which is one of the largest plants in Abu Dhabi, which is also from Aquapower. And we have built several of these kind of plants and reached a total capacity of 7.6 million cubic meters per day, which makes us the largest desalination company of the world. So that allows us to think loud about the different technologies, and based on the long experience in operating that, we see that on the technical challenge, today the desalination is dominated by the membrane process, which is called reverse osmosis. Despite of large plants in operation, there is some care needs to be taken on the pre-treatment of the system to make the plants reliable. The thermal systems were dominating for the last decades, but they have completely been ruled out by the membrane technology, which is only 1/3 of the energy. We also look from the innovation side for new technologies, and we are testing at the moment one technology which will even improve the economics of the RO. And so from the technical side, there is existing technology which can provide this water reliably. What needs to be considered is that the operation of the plant, it's a complex plant, and it needs an experienced team to keep that really at very high availability. The future technologies will be membrane-free, will reduce the energy consumption further, and also operate at lower recovery, so that the seawater, which is used and concentrated, returns to the sea, is almost considered as seawater again and not the brine, because of the lower concentration. So from the questions you had, from the technical perspective, hydrogen plants typically on the coast, so that's where seawater desalination are. The difference is we are limited on the renewable side, because typically renewable energy projects are not on the coast because of the humidity of the salt-laden air of many factors, and especially in Morocco, we also a first mover in Morocco in terms of concentrated solar power. We built the largest concentrated solar power plants in Morocco, and these plants are quite distant. So that rules out the direct combination of CSP with desalination, which brings us back to the option of like photovoltaic plus battery plus connecting lines, which we call the decarbonization of desalination in Saudi Arabia. So I hope this answered some of the aspects of your question, but we're still here for more answers if necessary.
Okay, thank you, Mr. Altman. Like I know that there is a lot of technologies, possibilities to combine both desalination and renewable energies. And now Mr. Brown, Mr. Jan Frederick Brown, who is a head of hydrogen cooperation in MENA region at Fraunhofer cluster. And I have one special question for Dr. Jan. How can water desalination for hydrogen production be integrated with other water management strategies, such as water reuse and conservation? Mr. Isfiou.
Yes, thank you, Ms. Salma. And thank you for also correcting your mistake. In Germany, titles are very, very important. So indeed, the doctor, although I'm Dutch. Just a few general comments, which I was also sharing with my co-panelists before getting on the stage here, is the emphasis on the role of water in hydrogen production a little bit. I mean, seems to be hype about the fact that water seems to be such a big issue when it comes to hydrogen production. But when you look at how wasteful we are with our own drinking water consumption and also drinking water transportation systems in Europe, but also in the MENA region, I'll sometimes wonder, and hopefully that's something we can also discuss later on, why is this such a hype? Why there is so much emphasis being placed on this? If you see how much water is used in fossil fuel productions, for example. But this is something that hopefully we can discuss more, because in general during this World PTX Summit, what I've been missing is an actual discussion. I see a lot of people coming up with presentations, but very little discussion. So I hope I'm throwing something here in the ring that we can also do interactively with the audience. Now, regarding your question, Ms. Selma, about water desalination for hydrogen production and how it can be integrated with other water management strategies, such as water reuse and also conservation. Of course, at Fraunhofer, we are the largest applied science organization in Europe. So we have a lot of ongoing projects. I'm not going to bore you to death with all of the details and the specific, but let us maybe two very brief examples that both have the word waste in it. So the focus on wastewater to hydrogen production, you have to also realize that an estimated 360 billion cubic meters of wastewater is produced each year, and that around almost 800 million people lack access to clean drinking water. So what we've been looking at Fraunhofer is like the simultaneous wastewater treatment, resource recovery of nitrogen, potassium and phosphorus, and also hydrogen production that could be a feasible option to clean hydrogen production without burdening fresh water. Another option that has the word waste in it is waste heat, the partial use of waste heat from the electrolysis process for the desalination of water that can supply the electrolysis itself and also produce and also make available the additional water for various residential uses. So those kind of applications, so wastewater usage, waste heat usage, that could be very relevant in this context. Thank you.
Thank you, Mr. Jan. And now we move to the third intervenant, Dr. Hamidi, who is President and CEO at Global Environmental and Sustainability and Cooperation, USA Group, ECOMED, and Desal in Morocco. And you have, I note that you have a lot of experience, more than 44 years in several fields such as management, environment, geology. And what about H2, which is the future generation? And I have a specially question for you. What are the environmental and social impacts of water desalination for hydrogen production, such as disposal of green and the distribution of water resources? Because we need a green H2. Thank you.
Assalamu alaikum. Thank you, Selma, for this introduction. I think I see here that I have a presentation. If I can run quickly through it, I'll try to be brief. That may should answer your question. Yes, my name is Ahmed. I'm founder of Global Environmental Sustainability. I'm sorry, founder of Global Environmental Sustainability (GSI), that we formed in the early '90s in Princeton, New Jersey, and you know, we've been involved in Morocco for many years, for 20 years now, through our affiliates. We have Group ECOMED that's doing waste management and waste energy in several cities in Morocco, including Marrakesh, and you know, Desal that deals with desalination. Today, I'm going to talk about the desalination and its relationship to the green hydrogen and renewable. So, do that next. Okay. As you all know, you know, seawater contains, you know, heavy dissolved solids from 30 to 45 milligrams per liter. Total suspended solids that are very high, pH 7 to 8, microorganisms bacteria and small amount of heavy metals. The desalination of the seawater has started, many years ago, as my colleagues, mentioned. It started, like in the early 50s, started with distillation systems, and then later on in the Middle East started with, in the 60s, 50s, and then the 60s, using basically a reverse osmosis that was the most, appropriate. Although, in the initial stages, reverse osmosis was very expensive, and only countries that could afford it were countries that have oil, such as the Middle East. It used to be in the 50s, it would cost like $3 per cubic meters to, treat a cubic meter of seawater. In the 80s, prices came down to $1.5 per cubic meter. And nowadays, with the new technologies in the reverse osmosis, basically energy recovery, the cost went down to around, $0.5 per cubic meters. The system is being improved more with the renewable energies, because the biggest part of the cost is the energy. So with the energy recovery for in the reverse osmosis system, and in the next one, and in the improvement in using other sources of renewable energy, such as solar, the wind, and hydrogen that's coming up, the cost isn't going to be lower. I'm going to talk about the without going further details into the technology itself. Many people know the reverse osmosis technology. I'm going to skip into the environmental impact that I was asked to answer for the, if you can slip through the slides. I'm not going to, detail the technology itself. A lot of people know it. Go further, please. One more, few more. Yeah, just go further until you get to the environmental impact that was asked to. Okay. I was presented. Okay. Potential environmental impact of the technology, as you know, include the energy consumptions. They are very, using a lot of, energy. So with the greenhouse, if the energy is from fossil fuel, the impact on greenhouse gas emissions. The other one is the marine life, impact on the marine life with the outfalls that are going to the ocean. You have a lot of problems with the environmental in the ocean, the habitat disruption. The biggest problem is the saline discharge, with the brine that's been discharged. So the brine has to be found solution to, either through the reuse of the brine or the discharge in longer distance from the coast. The energy sources, we talked about that, the infrastructure development, and the chemical use. All the technologies use quite a bit of chemicals for the pre-treatment and the post-treatment of the seawater. So those chemicals have to be taken care of and taken into account during the treatment process. Another slides, please. For mitigation measures, of course, the energy efficiency is one of them, and with the use of the renewables now, we can get to better technologies and most efficient technologies for the application of the desalination. So the renewable of energy is one of them as a mitigation measure. The improved intake and outfall discharge. So it has to be further away in the ocean. The brine management, either through the dilution or through the reuse of the brine. Obviously, the monitoring is, an important mitigation measure. The site selection, that has to do with where you're going to install your plant and take into account the environmental impact and the sustainable, sourcing. Thank you very much.
Thank you, Dr. Hamdi. Thank you, Dr. Hamdi. I know that there is a lot of environmental impacts from desalination, but fortunately we have a lot of mitigation measures for to attenuate this impacts. And now, because I let the audience to participate in any question, any debate, and I invite my colleagues here to exchange. If there is other challenges must be addressed between the nexus hydrogen and the desalination water, and you can now the discussion is open. Thank you.
I have my name is Thierry Lepage from Hadiel. I have a question which does not relate directly to water, but relates to oxygen and water. One of the things, and I know it's not going to be an easy question, but the production of hydrogen entails the production of oxygen close to 10 times more. We all know that one of the major problems of the oceans, where this desalinated water is going to take from, is that it's becoming more and more acidic. Do you think there would be a way to use the extra oxygen that we're going to produce in large scale hydrogen and to put it back into the oceans? Or in other words, what can we do with the oxygen? I know it's not right, but it's linked with water, because we have an issue with water. In our case, planet is warming because the oceans are becoming more acidic.
Mr. Brown, maybe.
This is a difficult question for me to answer. So let me be honest in that.
Well, thank you for the question. It is really interesting that all this oxygen, there's not really a good use case, but there is one. The problem, in my view, from our perspective, is not the technical problem. It's a contractual problem, because the projects are developed independently, and it's very difficult to mix different projects together. So in the case of a large hydrogen project, the desalination is included, because you need it basically to produce the hydrogen to the electrolyzer, to bring the hydrogen through the water. So what can you do with oxygen? I give you one example. It's called Brighton cycle, supercritical CO2 from net power. So you basically take, instead of the air in the combustion, you take oxygen from the electrolysis, and you get emission-free electric power plus pipeline-ready pure CO2, and you can pump it away. The problem is, what I said, is contractually. This project is not part of this project, and to make it happen becomes very complex. So if there's a way to think bigger, or the question is, are we thinking big enough when projects are developed? Yeah, when hydrogen projects are developed, usually it stops with the battery limits of the project. I think as a nation, we have to think bigger, or the nations, yeah, and look at downstreams, upstreams in all directions. Water is one issue, oxygen is one. But using the oxygen, I cannot see really how to stop the acidification. What we do is, in Aquapower, we have a pilot running to take the CO2 out of the brine, which is the concentrated seawater. We are doing two things. Out of 22 pilot plants which we have, two are maybe more relevant here in the context of the water and acidification. One is we take the CO2 out. That's we're working with a startup from France on that one, and we're exclusively testing that and reutilizing the CO2 in the desalination process. But this is one. The second one is everybody talks about brine is an issue for the environment. So our approach is not to produce the brine in the first place. So then people say, how can it be? You concentrate seawater, and how you cannot have brine? It's only a question of definition. What is brine? Brine is a concentration. What we know is brine from seawater desalination is a concentration of 70, 80, 90 grams per liter. It comes out of the reverse osmosis process, for example. Why it's this high level of salt? Because of the economics of a desalination plant with using reverse osmosis. You need the optimum recovery, which is depending on the seawater between 35 and
I think I throw a question back in the audience, which I mentioned earlier, about why there is so much emphasis on water usage in hydrogen production. I think it's I was discussing it with my co-panelists briefly before the panel. When we look at the water usage in the production of fossil fuel-based products, when we look at how inefficient our water transport are, I just recently read that in Italy, for example, 30% of all of the drinking water is wasted due to really inefficient infrastructure. So I really wonder out loud, why do we always, when it comes to hydrogen production, it's such a big issue? So that's one thing that I would like to also hear from the audience, share their opinion on.
Thank you, Mr. Brown. The other question, and you have something to add, Mr. Dr. Hamidi? Okay.
Good afternoon. Jawad Kharraz, Executive Director of the Regional Center for Renewable Energy Efficiency in Cairo. And at the same time, I'm the board member of European Desalination Association. So it's more a comment rather than a question. I mean, the connection between desalination or water and green hydrogen is not the question of technology. Technology is there. So as you explained it, I mean, we use RO, we have, mature technologies, and it is not an issue. The issue is obviously of planning, because in such a region, the MENA region, in Morocco in particular, we have the water scarcity problem. So, we have suffered consecutive drought seasons the last years. So there is a problem of water, obviously. And the last desalination plant that was built and now operational in Agadir, H2K, is producing half for drinking and half for agriculture. So there is another use, which is agriculture. And now the third use now is for green hydrogen. So the question is, we need decision makers. The level of water, energy actor need to coordinate more to plan for the next plan. So to plan for desalination plants, you need at least 3 years for the commissioning and then start operations of the desalination plants. So we need, to plan earlier this kind of project. So I know Aqua Power, so you work in the water and energy sector. Probably you have green hydrogen project in the pipeline. So do you have any project, desalination project that is expecting as end use green hydrogen? I'm just wondering. So, but again, I'm wondering here the importance of the nexus water energy and including food. That is very important to coordinate further between the stakeholders in the energy and the water, and eventually the food sector as well. And the last point, if you allow me to announce, we are organizing a big conference in Frankfurt next February 12-14, with the Khema company. It will be focusing on desalination and hydrogen. So to go deeper a little bit in the R&D of both sectors. Thank you very much.
Thank you, Mr. Hagas, for this important event to note. And just to add to answer some of your proposal, especially in Morocco, we have a planification, a strategy from desalination, which include all needs. Today we have needs from water, potable drinking water needs, agricultural, because now desalination from agricultural is a reality, is a business case that is suitable from Morocco, and also from industry. And OCP, like OCP, uses desalination for years, and it has an ambitious program. And we have in a government the watch to include the H2 needs of water in this needs, and just to not be to say, like I say, a few some figures. H2 doesn't need enough water like other needs, for example, from other industries or agricultural or drinking water. So it's not a big challenge to introduce this planification. Just the challenge is to have the coastal, because maybe like I have stressed, the hydrogen industry needs coastal areas to be implemented, because to have less cost for logistics. And so, especially in Morocco, where we have a lot of coastal areas, it's opportunity. Maybe for other countries, we don't have enough coast areas. It will be a big challenge, and they must do maybe other technologies from hydrogen to be more competitive. Thank you.
Yeah, thank you for explaining the reasons from your side, and it's very interesting. I still believe that the discussion is overrated, because I think it was mentioned that the amount of water which is consumed, not for cooling, which is actually consumed, is very small. And I think your question was if we are looking for a hydrogen project. In fact, we are partner of the large hydrogen project in Saudi Arabia. It's between Air Products, NEOM, and Aqua Power, equal partnership. And this is the largest project in the world, and also I think one of the few which are really in construction. It's certainly the largest in construction, and I'm not aware of any other one of this size or even close to that in construction. So if you look at 650 tons of hydrogen per day, we need only 9,000 cubic meter per day of water. 9,000 cubic meter per day is probably less than 5% of your Agadir desalination plant. So why it's an issue? You can easily extend, put another RO train, half an RO train in Agadir, and hydrogen for the largest project in the world is covered. So, but I do understand where you're coming from, and in Egypt, for sure, coastland is a prime property. There may be a lot of issues to get access to land. Also, brine was mentioned. We are working very hard on a brine solution. There's a lot of discussion about brine, and also here we have different ways of looking at it. I'm reading a lot of reports, and unfortunately, these reports are referring to the thermal desalination technology when it comes to brine. There is no thermal pollution with RO, there is no heavy metals in the brine, and the chemicals are reduced continuously, which are added to the process. We also just changed our strategy to replace some of the chemicals with carbon dioxide. So we're injecting basically carbon dioxide in the seawater to do different duties and remove organic chemicals which would otherwise go back to the sea. And as I also say, we can also recycle the CO2 from the brine and put it back into the seawater. So there is that's a patented process which we are applying in our plants. So there's a lot of things going on, and I think we can slow down a little bit and focus on the real problems of the world. Water for hydrogen is probably not on top of the list.
Thank you, Mr. Ra.
Yeah, just one thing I also would like to add. There's also, that was something that was brought forward by my Dutch compatriot Ad van Wijk, who is going to publish an upcoming book, How Hydrogen and Electricity Carry Our Future. that this emphasis on water scarcity and on water stress, it should be better, or it could be a more constructive alternative to think about the point of access of water, like was mentioned in the introduction. You know, I mean, the extra cost of transporting, whether it's fresh water, it's seawater, seawater and brine, over thousands of kilometers, the extra cost that comes with it is very, very limited when you look at the production cost of 1 kilo of hydrogen. So really, he like mentioned to me, because at Fraunhofer we also have a lot of modeling where we look at regions with a lot of water scarcity and a lot of water stress. But he pointed out that it might be much more relevant to talk in the terms of points of access, because those costs of transport are really so little. I just wanted to add that.
Thank you, Mr. Brown.
Yeah, I just want to add one thing, since you talked about, the planning. We don't have to always think, big. We need to have, very large, green hydrogen and desalination plants. There is a need for small ones. And I understand the economy of scale and all that stuff, but technologies are improving now that you can afford to have it for smaller units. There are a lot of small villages along the coast. There are fishing villages here in Morocco. There are a lot of brackish groundwater here in Morocco in areas that are far from the coast. And the technologies are available to use that. And it makes more sense, regional development, local development, than having, large plants in some, and we have experiences with large power plants that are far away and found out it's cost to, bring the energy from there to other areas. So we have to think of small units also.
Thank you for this point of view. And other question, please. Backside. Excuse me, from the backside. The backside.
Hello, and thank you for the opportunity. My name is Ahmed Hamad. I'm a
Hold on here.
my name is Ahmed Ahmad. I'm a journalist from Morocco World News. I just have two quick questions. One directly to you, Mrs. Jariri, and the rest to the panel. The first question is, water scarcity has been a problem in Africa, particularly in Morocco. What are the measures that are being undertaken by the government to tackle this question? To tackle this problem. And the second one, to the rest of the panel, what are the innovative measures that can be adhered by the Moroccan government to tackle this problem? Or what are the measures that your companies can assist the Moroccan government to tackle this problem? Thank you.
Thank you for this question. Because Morocco, we have a cycle drought, so we don't use desalination. It's not a new technology for us. We have beginning desalination, bleeding desalination treatment plants in the 70s. Now there is more than 45 years when we experience desalination plants in Morocco, and we began with very small desalination units, and after we mastered our plan, we have experienced different technologies, and after now the development is last said by Mr. Altman, it's the reverse osmosis desalination, which is the more efficient in capital cost and the OPEX costs. And so we know how to deal with the desalination units case by case, with small units, medium units, and big ones. And we have in Morocco more than 20 desalination plants with very sizes. And so this is our, we have a resilient with the question of scarcity of water, and desalination is the most costly from other technologies, and we do it in the last solution. But now with the drought, it comes a competitive solution with others like reuse wastewater and transport water and other technologies. Thank you. For the second question.
So maybe just one very general thing, so I'm from the Netherlands, but also in Germany, we still flush our toilets with drinking water. That's just ridiculous. And there's a million examples like this, how you could be more efficient with like drinking water. I also think that a lot of water stress comes from incredibly wasteful usage. And yeah, I mean, that's just one example, but there's of course a lot more.
Thank you. Thank you. Okay. Question?
Morning. My name is Youssef, working at Innovix. We've been hearing a lot about turning the brine problems into an asset by recovering metals and minerals from the brine. Just want to know from your perspective, is there any business case, mature technology to do it, or is just a way to communicate about how good we can do regarding desalination technology?
Yeah, this is another hype we're experiencing in many conferences to talk about brine valorization. As a developer, we need to be result oriented and develop the lowest possible tariff. So when we checked several of the methods which are available for brine concentration, all of them takes a lot more energy than the desalination process itself. So for us, it's not from a technical point, we understand and it can be done. But from an economic point, if we do that, we would lose every single bid we are participating. So as long as there's no incentive from the government to enforce it or to put the law to concentrate the brine, it will not happen in the tenders for the normal desalination plants. But also the effort to get minerals out of seawater is quite significant in terms of energy, in terms of you need actually chemical factories to do that. And all to build all these chemical factories to transport the equipment, all of that has emissions, all of that has also negative impact on the environment. So we don't have a business case as a developer because we are selling water and electricity, and concentrating brine would mean for us to increase the tariff. It's a similar scenario like we have seen with carbon capture in power plants. We are more than happy to do that, but nobody wants to pay for it. So if we add carbon capture to our power plants, and anyway, we're decommissioning all the fossil power plants. Our renewable energy is increasing dramatically every year. But still, if we use carbon capture in power plants, in the old ones, then the tariff will go up and nobody wants to pay for it. So that's the problem.
Thank you. Last question, maybe? No more question? Just something to add? And okay, look, I hope this session had evidenced the deep link between desalination water and the hydrogen industry to build a new economic and social system based on principles of sustainable development by drawing up strategies integrating growth, environment preservation, and climate change mitigation. As pointed by our minister this morning, the economic challenge is to be addressed by hydrogen competitive business plan. Thank you for to all participants for your presence and active participation.